Hello, welcome you all to the YouTube channel Effectual Learning. Today we look into magnetic field due to current, or in other words electromagnetism. You can find this 3D interactive simulation under magnetism at the website effectual.github.io. The link for the web page is given below in the description for this YouTube video. When a current is sent through a wire, the nearby magnet is put into motion. You reverse the flow of current, the nearby magnet movement also changes. The flow of electricity moves the magnet, and the wire that carries the electric current behaves like a magnet, indicating that electricity can be turned into magnetism. The effect of magnetic field due to current dramatically increases when the wire is coiled, as we see here in the 3D visualization. Take a closer look how the magnetic fields are more concentrated at the center of the coil carrying current. The current flow creates a magnetic field around it with north pole and south pole, direction of which can be changed when the current flow is reversed. If instead of a single coil, we have multiple closely packed coils, we can create a strong electromagnet. This closely packed coiled wire loop is called a solenoid. Inside the solenoid, the magnetic field lines are parallel and points in the same direction, forming a closed loop outside the solenoid. Magnetic field lines points outward at the north pole and inwards at the south pole, as in a regular bar magnet. The polarity of the north and south pole can be flipped when the current flow is reversed. The final form of coiled wire is the toroid, a long, closely packed coil in the form of a donut or torus is called a toroid. When current flows through the toroid, the magnetic field lines are looped inside the coil. In ideal case, all the magnetic lines are trapped inside this toroid in the form of a concentric circular loop inside it. The visualization of the magnetic field around current carrying wire can be done using Fleming's right-hand thumb rule. Here, the thumb points in the direction of current and the fingers are curled in the direction of the magnetic field. For a straight wire, when the current is flowing upward, on the left side of the wire, the magnetic field points towards the viewer, represented by the dot, and on the right, it points away from the viewer, represented by the cross. Visit the website for Physics 3D interactive simulations and see the effect of visual learning the effectual way.